All right. Okay. Well, first of all, I want to welcome everybody to our second asset management webinar. My name is Randy Lee. I'm the Assistant General Manager for the Inland Empire Utilities Agency. Very honored to host the webinar. And we have a couple of really good presentation today ready for you. First one is from Lonnie Good, and she will be present a case study on asset management at Castro Valley Sanitation District. And the second presenter is Katerine Fleming. She will be presenting streamlining your PACP inspection data using risk-based approach. The schedule for this is we'll have Lonnie present first, and then we'll have Q&A at 11:25, and at 11:30 we'll go to the second presenter. So I am just going to hand it over to Lonnie. Lonnie, this is all yours.
Great, thank you, Randy. I'm going to jump right into the presentation and give you an introduction here to Castro Valley Sanitary District's program. So Castro Valley Sanitary District is in the San Francisco Bay Area. It's in the East Bay. San Francisco is here to the left, if you can see my mouse pointer. That's the San Francisco Bay Bridge in the city of Oakland. So they're just to the east. And they are challenged, like many Bay Area agencies that are old and dealing with aging infrastructure. They have high I&I rates. Their peaking factor in a 10-year storm is approximately 9 to 10 peaking factor between dry weather and wet weather events. And they have a lot of pressure from the public to keep their rates very low. They have some of the lowest rates in the area. So they also have some unique challenges with the age of their system. So they're made mostly of clay pipe, of VCP, that was installed here in the red years or before 1955. So just an FYI, 1956 was kind of a catalyst year with VCP pipes where the rubberized gasketed joints began to be used. And so it created a much better seal on the joints. So any pipes installed before that have failed mortar joints, every 2 to 3 feet, which allows roots and I&I to often overwhelm the system. So they're in a challenge situation with about half of their pipes being in this red zone. So we joined them over the last 4 years as a consultant to support their program. And I wanted to give everyone an idea of what a small agency, this agency has about 150 miles of pipe and 8 pump stations. I wanted to give everybody an idea of what a small agency can do with a fairly limited budget. We used about roughly $100,000 in consulting fees to kind of advance this program every year for 4 years. And so I wanted to kind of take you through their asset management journey, not with it being a destination. It's one of my favorite phrases. And we did, just to give them a place to start, we did somewhat rely on the WEF Simple model, which is the Sustainable Infrastructure Management Program Learning Environment. If you are just starting out or need some advice on where to go next, this is a great program that I encourage you to take a look at. So phase 1 was really to empower the data. And I'm going to walk through these 4 sections: empowering the data, gravity sewers, the gravity sewer program, their pump station program, and then optimizing the program at the end. So the first step in empowering data is to start by setting program goals and objectives. And some of these include, improving service, maintaining a cost-effective and efficient work practices, reducing hot spots and making the system more reliable, complying with regulations, like reducing the risk of SSOs, reducing I&I, and so forth. And after they set those high-level goals, which included getting the general manager involved, looking at goals set by the board of directors, and trying to really define those well, it sets the stage for the goals of the whole program. So the program we set up is trying to satisfy all of these. The next step they did, I've put a bullet at the bottom here, setting a vision for their data and risk management. So we started out with kind of a flow, data flow module and setting up really the heart of the program, which is developing a risk management tool. And so there are pieces of the collection system information that go into this, such as their CMMS system, which just happened to be Lucidity. Their CCTV data comes in, GIS, of course, for the pipelines, and they have a hydraulic model, which has flow rates and capacity information, all of this coming into one risk management tool. And this risk management tool is really important to set the stage here and develop analyze risks, because it's the prioritization system for the rehab replacement program, for the maintenance program, for inspections, you name it. So once the system starts to get into that state where it's aging, if you have a brand new system, you're not worried about rehab and replacement yet, and you might not need to prioritize maintenance functions. But once the system starts aging, it does become really important to prioritize those resources. So that's really where this was all set to go. Another important factor in empowering all of this data, it's a lot of pieces, it's a lot of information, and a lot of data crunching gets done, but it's important to keep the objective in mind that garbage in and garbage out, whatever we put in this model is going to, the better the data is, the better the results will be. And so I put some green bars here down at the bottom, which are just kind of pieces of wisdom, I guess, that I'd like to pass on. But I always, while I say, garbage in, garbage out, I want everyone to remember that you can't let that, the data doesn't have to be perfect. We use the best data we have to make the best decisions we can, and we can always come back and refine it later. So I think that's important. But in Castro Valley's case, they had 4 different softwares for CCTV data. And some of these were from contractors where they had individual database, a single database for every single pipe that was inspected. Some of it's also more consolidated, but quite a bit of data crunching had to go into that to compile all of this data into one piece, one data set. And then it goes through the risk model along with the Lucidity data, the GIS, and the hydraulic model information. So phase 2 then, once you get your data ready to be able to process it, phase 2 is the gravity sewer asset management plan. And this asset management plan included defining those levels of service and documenting it so everyone can be clear on what the goals are. It includes improving the asset inventory and running some summary information on the pipelines, on the gravity sewers. It included condition assessment information. It included a risk assessment, both for pipes that had CCTV data and pipes that didn't. And it also included their rehab and replacement program, and it prioritized their CCTV inspection program so that they could close the gaps on collecting the CCTV data as soon as they could for the most important pipes first. So just to give you an idea of a couple of pieces of this, the gravity sewer condition assessment results, I mentioned that they had 4 separate databases. You have to kind of deal with the fact that you have multiple inspections. This sheet shows each color is a different inspection. So this actually had 4 different inspections from 3 different databases for this particular pipe. You're doing a lot of cleanup of assets, linking for pipe IDs that don't match, dealing with video quality challenges, combining partial inspections. So if you've inspected the pipe from the downstream end and the upstream end, making sure that those are combined into one inspection, correcting miscoded defects, that kind of thing. So another note here is as you go through this process, it really helps you refine your data collection protocols and really helps you discover, once you start looking at this data, it helps you discover ways to make your CCTV inspections more usable in the future and to kind of avoid some of this data processing in the future. The next step is that data, the CCTV data, goes into the risk assessment. I won't go into a lot of detail on the gravity sewer risk assessment because Katerina is going to cover it in detail here in the next presentation. But I just wanted to give you an example. This is fairly typical for gravity sewers to look at the 3 major failure categories for the likelihood of failure, using the structural failure from CCTV defects, maintenance failure and capacity-related failures or overflows. And we define, in gravity sewers, it's easy, you can define a failure as an SSO. And that kind of gives you an idea of where to draw the line and how to do this analysis. But we did use proxy data for the installation year, the age of the sewer, in areas where we didn't have CCTV data. So sometimes you can, if you don't have your whole system inspected, you can find something that represents the same results. So we were able to link, we did an analysis that showed that in their system, the older the pipe, the more defects it had, just as a general trend. So we were able to use installation years in quite a few pockets. I think they had about a third to a quarter of the system that hadn't been inspected when we started this process. Then we look at the consequence of each pipe failing and having an SSO on it. So we used, these are very typical factors like environmental impact, how close is it to a waterway, public health impacts, how close is it to a school. This graphic on the right is actually, the purple blob is an elementary school where there's a sanitary sewer running right through the middle of the schoolyard. And there's actually a manhole in the baseball diamond there. And then, and this pipe also has debris and sags and all kinds of stuff. So this particular pipe was of concern, considering the fact that if it overflows, there are children around and walking to school. So we did a proximity analysis. The farther away from the school you get, the lower the risk of public exposure becomes on each of these pipes, because children are walking to and from school and playing on playgrounds. So that's just an example of one of these, but you can also use community disruption, emergency response time, like poor access or pipes and easements that are difficult to get to. That can really affect the consequence of an SSO happening in that area. So we ran that full analysis. The first round, we did a very simplified version of just having 3 levels of risk, the lowest being low risk in the green, medium risk is yellow, and high risk is red. And so this allowed us to kind of get that baseline to move forward to the next step. It allowed us to prioritize a rehab and repair program where we started with the most high-risk pipes first. Rather than just going through and filtering out, structural 5s to repair, we started with the pipes that may only have structural 4s or 3s, but were had a high consequence of failure, like they were by a creek or in the middle of a school, those kind of things. So we were looking for both the balance of the risk on both sides. And then those results helped us prioritize their CCTV inspection plan. So we gave the crews a list of pipes, starting with the red pipes first, to start inspecting and working their way down to the green pipes. And so I will warn you, when you set up a prioritized CCTV plan like this, that does inspect the highest risk pipes first, you are inspecting the worst pipes, or the most likely to have a lot of defects first. So it does take longer to inspect these pipes. These are often pipes that are in easements that are hard to get to, close to waterways. They can be large diameter pipes because they have a lot of flow in them, or the older pipes that just plain and simply have a lot of defects. But the cool thing about the program is after the first year or two, and you've started to move through this, you also, of course, out of those high-risk CCTV inspections, you also get a lot of repairs that are needed. But once you start this program, you kind of get the worst part over first, and then you really start to feel like you're making progress. In the following years, it gets easier and easier. But at least you've managed your risks well and done the best you could with the limited funds you had in that first year. Phase 3 for Castro Valley was a pump station asset management plan that included the levels of service. We also had a new asset inventory and classification system for them. Before this, they had a pump station in Lucity. Their CMMS system just said they had 8 pump stations, and so they had 8 assets. They had started to develop a spreadsheet list of some of pump models and other major equipment, but we went through and inspected it and developed a full asset inventory, and they then were able to import that into their CMMS system and have better tracking. We did a condition assessment, a risk assessment of the pump stations, and a rehab and replacement program. So that condition assessment, we looked at both condition on a 1 to 5 scale, which is shown here in the pictures, from a visibly visibly good shape asset or mechanical asset, all the way down to one with high corrosion showing and clearly starting to show wear and tear. But we also looked at performance ranking. How is it functioning? You might have a brand new pump that vibrates and is running off of its curve that's not functioning well. So it's important to look at both sides of those. And out of this condition assessment results, I mentioned having a big table of inventory. I know you can't read this, it doesn't matter. There's a lot of really good model information, sizing, all kinds of information on all of their assets that got classified into a system. It's easier to project costs and for repairs once you know this information. So they were able to import that back to Lucity. Then they also got a nice report with pictures, and they have kind of the rating scales and notes of what needs to be improved and all of the information that's collected on each of the assets. And then we used that information from the condition assessment to run a risk assessment. We start by running the risk assessment. This little graphic on the right shows that we look at the individual components first. When is that pump likely to fail? Is it at the end of its life and not functioning well? But what's the consequence of that pump failing? Do we have a backup? So that might mean we're only losing redundancy. Or is it the MCC that's failing and you only have one MCC? So if that goes down, the whole station goes down. So we're looking at it component by component. Then we drill that up to the pump station level. And we start to look at other factors like spill volume, human health impacts, very similar to the gravity sewers, but also looking at emergency response impacts like overflow response time, bypass connections, and whether there are kind of redundancy factors built in, and backup power, of course, can affect how likely this station is to fail. And then we get results out of this risk assessment for pump stations in a couple different ways. We do get that graph of just like pipelines on the likelihood of failure versus the consequence of failure. But you can also show results in graphics like this that really help, I think, present to, say, your city council or your board of directors, showing you the relative scale of each of these. So each of the pump stations is shown on the bottom. And what this shows is the dot is kind of the median, the middle of the medium risk assets is the number of assets that is in each of these risk categories. So it's just one way to look at it. We draw a line in the middle of their assets, their pump stations. This isn't, on an industry scale or anything by any means. It's just to let them know which pump stations are worse. So if the dot is above the bar, this station has more red and orange, and the ones that have more green or low risk assets are below the bar. And so for this particular agency, we had the agency had just done some minor upgrades to pump stations 3, 4, and 5. And as we would expect, those are now lower risk. They were probably up just above that line and probably in line with some of the other pump stations before those rehab projects. They didn't get fully rehabbed, they got partially rehabbed, so they're not, way down here. But it's a great graphic to go off of, and it kind of lets them know that maybe pump station 1 is the next one that they should start to tackle. So then that helped us develop a 5-year rehab plan for those 8 pump stations, just identifying, correcting some of the condition and performance defects, adding some bypass pumping and other emergency generators, and also upgrading some safety features. So then the last phase for their program is to go back and optimize. Like I mentioned, asset management is a journey, not a destination. So one of the things that we were continually trying to do was identify ways that we can make it better the next time around. One of the first things we did was refine the pipeline risk assessment from 3 risk levels to 5 risk levels. We then were able to use that new risk assessment and all of that other data to validate their chemical root control program. So the root foaming program got prioritized by the same schedule or by the same system. We conducted interior and exterior condition assessments of the above ground creek crossings because those were they had a lot of aerial crossings of creeks that ran right across the creek with pipe supports that may or may not be failing. and what really wanted to manage those. And so we did a condition assessment there and started to analyze those a little further. We performed exterior condition assessments of 2 force mains and ended up replacing and realigning one of them to help reduce the risks of that force main. And then we implemented, and they're currently in the middle of implementing a new private sewer lateral inspection upon sale policy to improve their I&I reduction. So they're looking at lots of ways to improve. We also, the first round, the risk management tool we used was an access database that we developed. The second round, we moved it in 2015 to InfoMaster Sewer, which is a commercially available software that the biggest feature here is that it allows you to create a GIS layer of all of the defects and allows you to kind of manage the CCTV data and the risk assessment all in one place. So we thought that that added a benefit in being able to transport it to other consultants who can use it a little easier than our custom access database. And it also helped us export to AutoCAD. You know, during the design phase, we can export where the defects are located, and allowed us some data processing improvements. And then we, inspect, run the condition assessment again, and the risk gets refined, and we define the rehab and replacement. We repeat the whole program all over again each year to develop their rehab and replacement program, and just to refine the program. So I just wanted to close with a couple of lessons learned after this kind of four-year program from beginning to end. I think it's important to understand what data is important and why, and to fill those data gaps. If you don't have CCTV data for part of your system, start to collect it once you realize how important it is. Also, inspect the hard-to-access assets, including your pump stations, first, or as soon as possible, because they're also hard to repair in an emergency. So that pipe might be hard to get to, so crews don't like to go out and have to knock on the doors because the manhole's in the backyard, or they can't get access to it. But those are oftentimes the ones where, if they do have an overflow, are just as hard to deal with the overflow or to repair. Document each decision process is important as well. We did some big reports that I showed you. That is important to do because if you lose a staff member or you've changed consultants, however you do it, those documents can really be important so that you don't have to repeat the process, so that people have faith in the system that you've developed and you don't have to start over. Also recommend keeping good records of pipe replacements versus rehabs like CIPP, or versus spot repairs. That can sometimes be kind of a big question in people's mind. If I have a CCTV inspection that's 7 years old on this pipe, how do I know that that hasn't been repaired yet? And so trying to kind of match all that data up, it can be challenging sometimes. So if you keep a good running spreadsheet of the pipe IDs and the location on the pipe where it got repaired, it can go very quickly. And then finally, when working with consultants or contractors, like CCTV contractors or improvement contractors, always require the data collection efforts to be submitted in tabular format for import into your CMMS system. So if you have a consultant modifying your GIS, or if you have CCTV contractors doing data, creating databases, make sure you get a big consolidated database at the end, and make sure you import it. Don't leave it on your system somewhere else or in your email. Make sure you import those. And with that, we'll open for questions.
All right. Thank you, Lanny. That was a great presentation. I'm sorry, I should have introduced Lanny Good at the very beginning because we're in kind of a time crunch. So just to abbreviate intro for her bio, she's an asset management practice leader at West Yotes Associates, and she specializes in wastewater collection system, I&I reduction, risk assessment, condition and capacity assessment, and regulatory compliance. She is also a past board member of CWEA in the San Francisco section. All right, so open up for question. I have one question from Veronica. Her question is, what is the budget for CCTV? And does Castro Valley have their own crew?
Castro Valley does have their own crew. They have two crews, one that usually runs a jetter and one on CCTV, and at times they can form a third crew as well. So the budget is a good question. I used to say during the economic downturn that you could CCTV through a contractor for say $2 a foot was kind of our rule of thumb during the downturn when things were really competitive. But I'd say it's more like $4 a foot now to jet and CCTV, kind of as a ballpark. And that can be specific, of course, to how big the line is, how much debris they're pulling out, that kind of thing, and whether they have to do night work and traffic control, it varies as well. But that's just kind of in the easy parts of town and residential streets, small diameter, you can usually cover it for around $4 a foot in in the San Francisco Bay Area, I should say.
Okay. I got another question. Given by Robert, given all the new activities you have undertaken to support asset management, was additional staff required to carry out those activities successfully?
So we worked as a consultant, kind of a staff augmentation, I'd say. The district did have two staff members, kind of a technician and an engineering tech, an engineer that in-house who did help support us in a lot of this. We did have a team of consulting engineers doing most of the data crunching, but trying to track down information we did a lot of workshops and hand-holding between the operations group and engineering on, factors that included things like, are these pipes difficult to access? They may be in an easement, but are they really difficult to access? We, literally sit down with field crews and have them highlight pipes and mark them up on a map and try to get as much of that data out of their heads and into GIS or into a risk model that we can.
Okay, that's all the question we have, and as well as time. I want to thank you again, Lanny. One last one. To sustain the effort, has the agency hired additional resources?
They have. I think right now they have 4. They did develop, in fact, kind of in the middle of this, a position for kind of a database technician to help with support all of their in-house systems, including GIS and other supporting systems. And so they did add that position. They are also a solid waste agency, and so they have several different departments to coordinate with, not just the waste collection system, but they use that, 25 to 50% of the time, to my knowledge. And then they did add another technician as well, and at times had engineering interns helping to consolidate some of the CCTV data, copying and pasting, and going out and even looking at the creek crossings and different field work whenever they could for even with temporary interns. So there is some support, definite support for a program that is needed to collect some of this data, and it does become a good focus.
All right, thanks. Thank you again, Lanny, for
you're welcome.
Presentation. Now we're switching to Katerini Fleming. She is the Regional Asset Management Leader for Black & Veatch in Southern California, and originally from South America. Katie earned her bachelor's and master's degree in civil engineering at George Mason University, and her past and current clients include County of San Diego, City of San Diego, City of Escondido, LADWP, DC Water, and others. She mentors high school students and loves to promote civil engineering career path. Great. All right, I'm going to turn it over to you now, Katerini.
Thank you, Randy. Can you hear me fine?
Yeah.
Okay, so let me just share my screen now. Let's see. Are you guys able to see my screen?
Not yet.
Okay, so let's see.
Might take a few seconds. There.
Okay, great. Okay, perfect. Thanks. All right, well, happy Valentine's, everyone. So first and foremost, I wanted to thank, for those attending this webinar and for the opportunity to present today. This presentation will describe the development and outcomes of the City of Escondido's ongoing evolution of their CCTV inspection tool, GraniteNet, integrated to their CMMS system, which they use as CityWorks. And then how we were able to help the city streamline that PACP data from the CCTV inspections and using a risk-based approach to grow awareness of the shape and condition of those pipes that were selected for these pilot. All right, I'm gonna skip that one. So just to help us navigate this presentation, I actually put together a table of contents with 5 areas that I will cover during this presentation, and I will conclude with the gravity main inspection pilot results. So what we have here is just to, this slide is to help us illustrate those critical milestones that were accomplished with the city, for the City of Escondido. We can see this effort started in early July, and where it was identified that there was a need for a gravity mains inspection program, which was followed then by a logistics meeting, a PACP refresher meeting, and then the field work, which started in September, and the pilot of those pilot segments were completed by late November, and then the data analysis crunching started beginning in December, and then the results were produced or delivered by January in 2018. So now let's jump to actually standard operating procedures. And what I want to cover, as well as we know, when employees follow an updated SOP for really any particular job, they produce a product or execute a service that is consistent and predictable, unlike when it is not up to date. So when we were helping the City of Escondido televise those pipe segments, it was really key to document all of those inspection steps, and most importantly, connecting the dots between the user and the City of Escondido's inspection tool, which in this case is GraniteNet. So basically now the SOP features screenshots of their GraniteNet software, which helps operators follow, and also this serves as a tool to onboarding new employees to provide CCTV inspections. So now moving into actually the gravity main televising, I will actually discuss and talk about the importance of NASCO training and certification, which was held by the crew as well as myself even before leading this effort. Now, this is my favorite slide of the entire presentation, not only because it actually reminds me of televising with Kyle and Josh, but most importantly, the significance of how we actually got those PCP results, right? For those of you on the call who may or may not know, these are entirely dependent on the quality of the PACP defect coding. Therefore, it's important that every CCTV technician or color operator has actually been trained for performing televising inspections. Hence, the City of Escondido ensure that all of their staff actually held a valid PACP certification in accordance to NASCO standards to assure that all pipe system data was collected and coded in a consistent and reliable manner. So now a little bit, I would like to go over some background on the City of Escondido, where 4,700 feet of CCTV inspections were conducted. A total of in about 6 drainage basins in which pipe materials were identified, including concrete pipe, BCP, and PVC. Now for the pipe years, gosh, we identified a range of from the late 20s all the way to the late 80s for just those 6 drainage basins. So the city of Escondido currently has about 12 crew members trained and certified who possess that valid PACP certification since March of 2017. The city has also a total of 385 miles of sewer lines. And I believe at that time we had one van dedicated to perform CCTVs, but I believe they're not currently in the process of getting another one, with a 2-man crew per van responsible for televising the entire system. Now, the city's, like I mentioned before, inspection software of choice is GraniteNet, which follows all those NASCO standards. Actually, one of those best products out there too for televising. So, action items that were completed before and after each field inspection included, like I mentioned, a review of those, the GNet PACP calculations and the scores. And we'll be moving now into the data analysis, which then I will be able to cover the fun part, the results. But so moving into that data crunching analysis, we realized the importance of collecting PACP data. So, and as we know, many of us, information is power, but it really is power if utilized wisely under actually good leadership. And, like the city of Escondido, for example, it can allow an organization to make more informed decisions. So what do we actually observe right out there in the field? So this is just, the purpose of this slide is just basically to illustrate those some of the most popular defects, identified within the inspections. We saw little pipe holes, root balls, multiple cracks. So also found surface damage and deposits attached within those pipe segments. So what next, right? So what do we do with all that PACP condition grades that, condition information that was collected? So evaluating the PACP condition grades was the next step. For those of you who are very familiar or not, a PACP, the GraniteNet will output a report that looks more like the one that we have in this slide with those condition grades, color and orange. Now each PACP code is assigned a condition grade ranging from 1 to 5, where 1 is a minor defect and 5 is considered a major. Now these condition grades are based on the significance of the defect, right? For example, the extent of damage, whether that crack, it's a longitudinal or maybe it's just a short for a specific segment within the pipe segment, or the percent of restriction to flow capacity, right? Or the amount of wall loss due to deterioration. Pipe thickness just starts decreasing. So now with these condition grades, then an overall quick rating is calculated, and not to get so technical, but just wanted to make it more graphically, friendly during this presentation. So I just got some screenshots of these, this information. That the very popular overall quick rating is a 4-character score, which is a short way pretty much of expressing the number of occurrences for the 2 highest severity grades. So for those of you you guys are familiar with GNet, it actually calculates it automatically. But I just wanted to, kind of discuss the relevance of understanding really the math behind these. Now the pipe rating index, which is the indicator truly of the overall defect severity within the line segment, and calculated by dividing the overall quick rating by the total number of defects. So let's say, for example, a 4 is the highest severity, as well as a 3. They take the place in the 1st and 3rd character of the overall, the quick rating. And these 2s represents how many 4s we saw, right, on that pipe, on that segment, and as well how many 3s do we see. set 2. So that's what this represents. I don't know, not really intended to get technical here, but once you guys are certified for those, they need to go through the whole training of understanding and learning how this works in order to also do some QA/QC. Comes really, really handy. So now really getting into the whole risk assessment, the first step is to calculate the likelihood of failure. And we heard the likelihood of failure, the LOF, in the previous presentation that Lani shared. But just wanted to give you an idea, what we had to develop for the city. We put together a matrix, which was developed with formulas to produce risk scores. We don't see it here yet, but we'll see it in the next slides. So the LOF refers to a calculated numerical representation that denotes pretty much the probability, right, whether that pipe segment is going to fail based upon the physical condition, and typically determined by the PACP survey reports, the one that I showed you in the previous slide. So the next step, which is the second step to assessing risk, is actually calculating the consequence of failure. So now we keep adding to this matrix. As you guys can see, this is just scrolling to the right-hand side. So the COF is actually a combination of direct and indirect impact on the vicinity and community to the pipe due to potential asset failure. It is typically having expressed in triple bottom line terms, known as people, planet, and profit. So now these concept, emerged in the 80s, and consideration of these three factors pretty much encourages, organizations like the City of Escondido to focus also on social and environmental aspects, rather than just solely, upon more visible, which is the economic aspect of management. So not truly a new term for those who practice asset management, right? Now, for our case, for the 16 selected pipe segments for the City of Escondido, we determined the COF for each individual pipe segment by considering the location, for example, and demographics, and a series of other weighting factors with different parameters, contributing to those three economic, social, and environmental impacts. So now, finally getting into the risk scores. But before getting there, I'd like to emphasize that having a regular and systematic inspection, in this case of gravity mains, it truly provides a means to, for the City of Escondido to monitor the condition of the pipes, right? Providing effectiveness of those maintenance operations by updating the SOP like the City of Escondido did. And pretty much this all serves as a basis for identifying and scheduling capital improvements, right? For helping the City of Escondido thinking more proactive and moving towards, okay, what do we do with all this data now? We already collected the PACP data in a consistent manner following the standards. Now we have an idea, the risk of these pipe segments. No, so what do we do next? So having all these, like Lonnie said, imported into a database really, allows that opportunity. So just looking at the risk scores, the last column on the matrix here on the right-hand side, we can see them, I will provide a better graphical representation, but typically, these scores, oops, went too far. Typically, the scores are also shown on a heat map, very similar to Lanny's. Likelihood of failure to the left-hand side, and on the other x-axis, the consequence of failure. Colors, which represent green, it probably doesn't require as much frequency of maintenance compared to the pipes that are more going towards the red and higher, right? Monitoring really the ones that are in the middle section. I want to say the orange color ones here. Very much having some significant defects. So calculating the overall risk is just simply a function of the likelihood of failure, which I cover, and its consequence of failure, right? So like I mentioned, COF in the green may need to be cleaned, inspected less frequently, and those in the orange, red range should be inspected definitely more frequently. And then for the city of Escondido to have an idea the place for these the pie segments, whether it serves a specific customers, stakeholders, whether it's close to a environmentally sensitive area, servicing customers with significant importance, let's say hospitals. So this graph just helped the city, have an idea, for the pilot of these the gravity mains here. So really getting closer to now my presentation. I try to go quick here so that I can allow some questions, but really before ending this presentation, I wanted to leave you guys with, but what if? What if an agency has no, systematic inspection of your gravity mains? What did you know about the location of your pipe, or whether it actually serves to significant customers, right? How would you know that? Or perhaps what if, what is actually the proximity to those environmentally sensitive features? Or better yet, any idea about, accessibility for maintenance and inspections? So having a routinely basis, like I said, it just provides a better basis for, taking action on potential capital improvement projects. Questions?
All right, thank you very much. That was a great presentation. Anybody have questions for Katerini? I have a question. Was there an impetus or an event that caused this asset management assessment on the sewer system to start?
Yeah, so there are a lot of variables here. So primarily just they had incorporated Granite Net in March, like I mentioned. The guys got certified in March of 2017. Not sure exactly what other tool they used in the past. I don't really think it was, one of those known tools. So it was primarily to, I guess, starting just having a consistency, for all employees, and really having a one place to start looking at all this PACP information. So the not having it was the push to find, to get to this step for the city.
Okay, all right. And anybody else has any questions? You can type in from on the chat box if you have any questions.
Randy, this is Alec. There is one from Patrick Fuss. Is there a recommended frequency of CCTV inspections? And second, how frequently is the risk model revisited?
Great question. So the CCTV frequency, it varies from the locations. I guess in this case for the city of Escondido, they are more aware of the drainage areas. So some areas are much older where pipes are known that are as, from the late 20s, rather than the newer developed areas in the county. I'm sorry, in the city of Escondido. Then the second question was, I'm sorry, what was the second question? Alec?
How often is the risk model revisited?
Oh, yes. How often? So I think they were talking and looking into actually, let's see, so it would just depend on the number of pipe segments that were being accomplished. They were trying to group them to make it more efficient. So maybe like on a twice, 3 times a year, they were visited. They had only started with a few pipe segments, so they're relatively new compiling all this information. So.
Okay. Anybody else has any other questions? Okay, I think we're done for today. Alec, do you have any anything else you want to mention on the CASA side?
Yeah, please join us for the fly-in the annual lobbying event in Washington, D.C. That's February 25th through the 27th in 2019. And then the next upcoming asset management events are, I had it here, Tuesday, April 9th, a full day workshop on getting started with asset management. Wednesday is a session on how we did it, so more successful stories. And Thursdays are several sessions again on asset management. So those are the upcoming events. And please shoot us any ideas for future speakers or other asset management topics. That's it, Randy.
All right. Thank you, everybody.
Thank you, guys.
Thank you. Take care. Bye-bye.
Bye-bye.